In this video, I'm going to show you how to factor trinomials. Um, Most of the time, our trinomials are quadratics, like these are that you see. They don't have to be quadratics, but typically this is the kind of problem that you would have to factor. And so it's a quadratic and it has three terms. That's a trinomial. So let's start. When I factor it, I start with the last term. And these are written in descending order. And descending order is just a way of saying we're starting with the x squared term, then we have something with an x term, x term, then we have a number, some kind of number. Okay, so some number back here. That's called descending order. Okay, and I have these all set up so they're in descending order. And sometimes they won't be. They might be kind of mixed up, but uh, but I'm going to put mine in descending order. So I can emphasize this. Start with the last term, which is a positive 3. All right, and think of two numbers that you multiply to make that positive 3. And what leaps to mind is a positive 1 times a positive 3. Of course, 3 is a prime number, so there's really not anything else you can multiply to make a positive 3. Later on, we can kind of get caught a little bit by kind of thinking that way, because also be aware that we can also multiply a negative 1 times a negative 3, and also get a product of positive 3. All right. So when I take a 1 and a 3, a positive 1, and now I turn around and add them up, I get. So I'm writing 1 times 4. Okay. If I add them up, I get a 4. So if you look at this, when you multiply, 1 times 3, I get a 3, and 1 plus 3, I get a 4. So that tells me what the factors are. Okay. I just write two sets of parentheses. Okay. My x squared is x squared. I know that I can multiply x times x, get x squared. Okay, and I just write a positive 1 and a positive 3. And those are my two factors. Okay, and a lot of times it's just as easy as that. All right, let's go to the next one. Our last term is a 5. So I can multiply 1 times a 5. Also, I could have multiplied a negative 1 times a negative 5. But when I add a positive 1 and a positive 5, I get a 6. So here, 1 times 5 is 5. 1 plus 5 is 6. Okay? So I know my factors are the 1 and the 5. X plus 1, x plus 5. Okay? Alright. Let's go down to the next one. Okay? So this is what I was mentioning before. Okay? Alright, we have a positive 7, so what comes to mind automatically, 1 times 7. But when we add a 1 and a 7, we actually get a positive 8, and you look very, very carefully, that is actually a negative 8. So this is where we could kind of make mistakes real easy if we go too fast or not really thinking, or just not thinking that, oh, a negative 1 times a negative 7, that also multiplies to make a positive 7. And when I add a negative 1 and a negative 7, I get the negative 8 that I'm looking for in the middle term. So my terms are, if I multiply a negative 1 times a negative 7, I add a negative 1 plus a negative 7. So I'm looking for my factors of x minus 1, x minus 7. And also we could have wrote it like x minus 7, x minus 1. Either way, it doesn't make any difference. Alright, let's go to the next one. Positive 11. Positive 1 times a positive 11. Negative 1 times a negative 11. Okay, we're going to pick the negative 1 and the negative 11. X minus 1, x minus 11. So typically when I start factoring with students, I pick prime numbers as my last number, because there's just not, there's only one way to multiply to make those numbers. 7 was a prime number. Okay, so we'll boost it up a little bit with the next problem, next few problems. Okay, so x squared plus 5x plus 6. Okay, so this is a little more interesting. I'll have a couple of options. Okay, We can multiply a positive 1 times a positive 6, or we can multiply a positive 2 times a positive 3. Alright, when I add 1 and 6, I get a 7. When I add 2 and 3, I get a 5. Which one is in the middle? The 5 is in the middle. Okay, so I need to use this combination with the 2 and the 3, not the 1 and the 6. So my answer is x plus, oops, so I almost made a mistake there, x plus 2 and x plus 3. Now let me show you a common way students can make mistakes. Sometimes they don't remember exactly the sequence, and they'll actually look at that 5 and say, okay, 1 times 5 is 5, and 1 plus 5, that equals 6. So they're going to say, well, I think the answer is x plus 1, x plus 5. Okay, and then be happy because they think they did well, but let's check it out and see. Okay, if I actually FOIL this, x times x is x squared, x times 5 is a 5x, the 1 times x is a 1x, and 1 times 5 is a 5. And when we combine the two terms in the middle, we would have an x squared plus 6x plus 5. Okay, and that's not our original problem. Okay, so be, pay close attention, especially when you're first starting. And I really can promise you, once you do several of these, it's just going to be just automatic. You're just going to be so good at this. It's like putting on a seatbelt in your car in the morning. You just now you're going to think about it. Okay, let's try the next one. Okay, a positive 6. All right, 2 times 3 is 6, but 2 plus 3, that equals 5. Now, how about 6 times 1? Okay, 6 plus 1 is 7. Okay, so, see, we're trying to make that 7 happen. We're trying to make the 6 happen by multiplying. We're trying to make the 7 happen by adding. Okay, so we're going to use x plus 1, x plus 6. Okay. Let's go to this next one. Okay, I see a positive 8, so kind of automatically always thinking about, okay, 2 times 4, well, 1 times 8 maybe. 8's not a prime number, but 1 times 8. Okay, 2, I see a 6 there. Okay, so maybe it's 2 and 4. Alright, so we're thinking, man, that was a 2 and a 4. Okay, but what's the problem here? Okay. And you can probably figure it out when you get to that point, but emphasize, this is really a negative 6. It says subtract 6, but we make that a negative 6. So we got to think about multiplying a negative 2 times a negative 4. Okay, those multiply to make it a positive 8. Okay, and a negative 1 times a negative 8 also. And then but the negative 2 plus the negative 4, that's the negative 6 which we are looking for. So negative 2, negative 4. Okay? Alright, let's try a few more. And they really, when you practice, they should go really just that quick. Okay? Automatically, let's see, 8. What do I multiply to make 8? And sometimes people can look ahead and say, wait a minute, okay, that's a positive 8. I got a negative there, so I might as well just go ahead and think about my negative numbers. Negative 2 times a negative 4, negative 1 times a negative 8. These are the ones, this is going to add up to negative 9. So sometimes you can kind of, when you practice enough, it gets easier and easier. X minus 1, x minus 8. Those are your factors. Alright? A positive 20. Okay, so we have bigger numbers. The bigger numbers, the more ways we can multiply. 1 times 20, 2 times 10, 4 times 5. Okay? These add up to 21, these add up to 12, these add up to 9. Alright, we got a 12 in the middle, so we're going to use 2 and 10. X, okay, it's a positive 12, so I'm going to use a positive 2 and a positive 10. And there are actually rules about, the plus and the plus, or the plus and the minus, and at the end there's a minus. But I'm going to save those, and I'll tell you those rules. I'm going to save those to the end um, because it's, just memorizing a bunch of rules, you forget them pretty soon, pretty quickly. So rather you think about these things I'm doing right now, practice them, and then the rules will be make sense. Okay, here's a positive 20. Okay, all right, 1 times 20. And again, you wouldn't have to write these down every time. Okay, develop your mental math. Looks like that's going to make that 9 right when you add them. So x plus 4, x plus 5. Okay, all right, a 24. Okay, all right, and you wouldn't have to write them down, but you might need to. You can judge that for yourself. 3 times 8 is 24. 4 times 6. Okay, when we add, that's a 25. That's a 14. That's 11. That's a 10. And I see a 11, but be careful. It's really a negative 11. So, negative 3 times a negative 8 is a positive 24. Negative 3 plus negative 8, that gets us our negative 11. So why? And you got to be careful with your signs. X minus 3, x minus 8. All right. Let's see. Got one more count like that. I got a positive 24 again. Okay. So if I kind of look ahead right there, that's a negative. So I can just kind of think about multiplying two negatives because that's a positive. Okay. I have to multiply two negatives or two positives to get a positive at the end. Negative 2 times negative 12, negative 3 times negative 8, negative 4 times negative 6. Alright, these two add up to negative 10. It's so good if you can add and multiply your signed numbers. Okay, so x minus 4, x minus 6. Okay, so next group I kind of offset a little bit because just to signal myself, but because all of a sudden I made a little change here. I put a negative number back there. Put a negative number in there. Okay, so go back to very, very basics. It's a negative 5. What do I multiply to make a negative 5? Okay, a positive 1 times the negative 5. But the other possibility is I could have the 1 to be negative and the 5 to be positive. Okay, one of them is right. Now if I add these up, I would get a negative 4 in this case with a positive 1 and a negative 5. If I add them, when I add a negative 1 and a positive 5, I get a positive 4. Which one is in the middle? It's a positive 4. So I need to use this idea. Okay, so x minus 1, just match it. That's a minus 1, so I subtract 1. X, and that's a plus 5, so I just put a plus 5. Keep your math as simple as you can think of. Okay, alright, let me scroll down. Okay, so and as you're learning math, think about what's different about these problems. Okay, here's a negative 5 just like that one. Okay, what's different about it? I can do a 1 times the negative 5, negative 1 times a positive 5. Okay, but this time, make sure you're looking. Think of that as a negative 4. We're going to use this one right here. Okay, 1 plus a negative 5. That makes our negative 4. So we're going to use a positive 1 this time. X plus 1, a positive 1, and negative 5. Okay. Alright. So we switch again. Now it's a negative 7. Again, I'm starting with prime numbers because our list of factors are very short because they're prime numbers. 1 times a negative 7 or negative 1 times a positive 7. Try to get that concept down. Which of those do we use? Okay, we have a positive 6. Okay, so actually I'm giving you a little bit of a rule already. we're going to use the larger number has to be positive in absolute value. The 7 is a 7 and a 1. Okay, 7 is larger, so that has to be the positive one. Okay, so we're going to use these. Okay, a negative 1 plus 7, that's our 6. Alright, so x minus 1, x plus 7. Okay, let's see, scroll down. Again, and you see the pattern you'll see the pattern. I got a negative 7. Alright, this one I had a positive 6. This one I have a negative 6. Just to show, this is a very good way to learn math. Okay, if I go back to very basics. Okay, negative 7. 1 times a negative 7. Negative 1 times positive 7. You don't have to write it. Just think of it. Think of it. Alright, this time I'm going to use this pair because they add up to a negative 6. So x plus 1, x minus 7 are your factors. Alright, let's make it a little more complicated. Let's give you something other than a prime number. Always, when I'm factoring, we're looking at the last number first. I'm always going back here to this last number. Okay, and eventually we'll practice somewhere. I'm always having a 1 there, and we could have something other than a 1 there. Okay, but these are the simplest ones where my my leading coefficient is 1. Alright, a negative 8. So it's a negative, so 1's positive and 1's negative. 2 times a negative 4, negative 2 times a positive 4, and sometimes we don't think of 1 times 8. That's definitely legitimate consideration. Alright, looks like we got a positive 2 there. So it looks like these two will add up to a positive 2. So a negative 2 and a positive 4, just write x with a minus 2, x and a plus 4. Alright, negative 8 again. Again, I'm pairing it up. It's probably pretty obvious what I'm doing. 2 times a negative 4, negative 2 times positive 4. This time, this is the one that's going to work, right? These two add up to the negative 2. You add these up, you get the negative 2 that you have in the middle. Okay, multiply to make the last number, add to the middle number. X plus 2, x minus 4. Okay. Again, trying to make it a little tougher on negative 12. Okay. Alright, let's see. Oh, negative 12. So 1 times a negative 12. And this would be pretty tedious, writing them all out every single time. And I would not recommend this. No, I would not recommend this. Okay. But if you need to, that's what you should do until you get better. Okay, I have a positive 4, so it looks like we're between these two. Okay, which will give us a positive 4. It'll be these two right there, the negative 2 and the positive 6, right? X minus 2, x plus 6. Okay, another negative 12. Okay, and this one kind of gets some students sometime because, what's the coefficient in front of that x? That's just a little old only 1. Okay, 1 times negative 12. In fact, I wouldn't even bother writing. Now I see that's not going to work. And the 2 and the negative 6 and the negative 2, the positive, those are going to give us 4, negative 4. Let's focus on these two. Negative 3 times a positive 4. Save some tedious. Not meant to be tedious. Okay, when I add a 3 and a negative 4, I get a negative 1. Okay, when I add a negative 3 and a positive 4, I get a positive 1. Okay, I have a positive 1. It's positive. So I need to use these, the negative 3 and the positive 4. Just like that, just that quick. Okay, and again, I will tell you the rules. Okay, much rather you learn this way, much rather. Okay, negative 12. Yeah, there's a bunch of negative 12s. Let's think about 1 and negative 12. That's going to give us the negative 11. Okay, so the negative 1 and the positive 12, I know that's not going to work. It's just going to give us another type of 11. All right, the 2 and the 6. 2 times 6, 2 times negative 6. Okay, that's going to give us a negative 4. I don't need to waste my time more than that. Okay, I give us one we can't factor. Okay, hold on now. 3 and a 4. Okay. Let me, wait, no, I can tell one. Okay. Alright. Trying to go too fast sometimes. Okay. The 2 and the negative 6 gives us a negative 4, and that's exactly what we have. So, x plus 2, x minus 6. Sometimes you just try to go too fast. I think I was looking at this next one. Okay. Alright, the 1 and the 12, 1 and the negative 12. That's what's going to give us 11s. That's not going to work. 2 and a negative 6, that's a negative 4. Alright, but 3 and a negative 4. Let's try that one. Is it 3 and a negative 4? Or negative 3 and a positive 4? These two add up to a negative 1. These two add up to a positive 1. Okay? We got a negative 1. Got to watch your signs carefully. X plus 3, x minus 4. Okay. Almost done. Now we've done a bunch of them. Alright, so yes, okay. So now I'm down to kind of like a special category. These are still the same idea, okay? But there's something special if you look on all of these. That's a 9, that's a 16, and that's a 1. These are perfect squares. You know, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 25, you know, so on. So, alright, so watch out for when the last number is one of these, because these are going to be called perfect square trinomials. Okay? Alright, and that's when the last number is that perfect square, not in the middle term. Okay, so how I do it? It's the same. It's saying, you know, just go back to your fundamentals. You know, how I get multiply to make it positive 9, either 1 times a positive 9, or a negative 1 times a negative 9. It's positive. Or I could say a 3 times a 3, or a negative 3 times a negative 3. Alright, so my middle number is a 6. Okay, so use the two positive 3's, right? It's a positive 6. So, x plus 3, and we'll have another x plus 3. And that's the reason why I brought this up, because a perfect square trinomial will factor into two factors that are exactly the same, x plus 3, x plus 3. Okay, so the main reason I want to go through this is you need to write your answer like this. When these two factors are exactly the same, you really have to write it as x plus 3 squared. Any time of multiple choice test you might take, it's never going to be written like this. I mean, I'd be very shocked to see an answer, one of an answer choice like that. Okay, so just be in the habit of writing that. Okay, and here's a quick way of factoring it. Okay, a perfect square trinomial, if you can recognize it. Okay, it's even a little bit quicker than what I showed you, which I showed you was quick. But just take the square root of 9, which is 3, and double it up. 3 times 2 is 6. So if this number is the square root of the 9 times 2, that's a perfect square trinomial. So the square root of 9 is 3, and you recognize it real quick. Okay, let's go to this one. Okay, that's a perfect square. Okay, square root of 16 is 4. Okay, 4 times 2 is 8. That's a perfect square trinomial, x plus 4 squared. Okay, now be a little careful. I mean, sometimes going that fast probably make a mistake. Is that a perfect square trinomial? No. Okay, so this is x plus 2, x plus 8. See, these are not exactly the same. You know there's a 16 back there. Not all trinomials that end in a perfect square are going to be perfect square trinomials. Okay, but the ones I'm showing you are. Okay. All right, and this one gets sometimes that plus 1. 1 is a perfect square. Okay. And the only thing multiplied is 1 to get 1 is 1 times 1. And then 1 plus 1, that's 2. All right. So sometimes we kind of, kind of neglect this one. Don't let this one catch you. Okay, it's 2x plus 1s. But again, practice writing it with the exponent. Okay, I've got a few more of those just to be just to be thorough. Is that a perfect square trinomial? Let's see. Square root of 4 is 2. 2 plus 2 is 4. Okay, the square root of 4 is a positive 2. Okay, and 2 times 2 is a positive 4, but that's a negative 4. Okay, so we have to kind of add that little idea to our rule. So yeah, it doesn't, if it adds up to the positive or negative version, it works. This is a perfect square trinomial. Okay, 2 times 2 is 4. Also, and of course 1 times 4. But negative 2 times negative 2 is also a positive 4. And they add up to a negative 4. Okay, so that's what we need. And they're exactly the same. So it's still a perfect square trinomial. Alright, 36, square root of 36 is 6. Ooh, I should not have had 16 there. Let me change that to, and see, this is how I design them. I just say, okay, so make that 12. So what would the answer be? X minus 6 squared. Okay, 6, negative 6 times a negative 6 is 36. Negative 6 plus negative 6, that's a negative 12. Okay. Alright, this one on the bottom. Okay, ooh, big number. Okay. Alright, so don't use 50, 10 and 10. It's not 50, 50 times 2 is 100. But 50 plus 2, that's 52. Okay, we just got a negative 20 there. Okay, so 10 times 10 is 100. But however, they add up to a positive 20. That's not what we wanted. A negative 10 times a negative 10. And then these two do add up to negative 20 like we want. So x minus 10, x minus 10. And if they're the same, don't be neglectful. X minus 10 squared. Alright, let's see what else I have. Okay, now this last group is kind of like more of a special situation. Say, oh, look at this one. Okay, this has a leading exponent of 3. But look carefully. This kind of disguise. Somebody kind of messed this up to make it look harder than it really is. Okay, this is x to the third. That's x squared. This is an x. Okay, all 3 terms have an x in them. So we can do a little common factoring here. You don't see it too often in trinomials. Really, that's set mostly for binomials. But let's see what we can do. X to the third is x, 3x's multiplied together. I'm just going to leave this 9. That's 2x's multiplied together. And that's 1x. See, all 3 of them have just 1x in common. Use the smallest amount. So I'm going to pull that x on the outside. Whatever is not, I didn't pull on the outside, I'm going to put inside. So the 2x I didn't circle, that's going to go on the inside. There's a 9 and an x right there. Okay, one of them was pulled on the outside, and there's just a plain old 14. Okay. Alright, well, can this be factored? Okay, 14. 1 times 14, 2 times 7, the 2 and the 7, 2 plus 7, that adds up to 9. Okay, so x plus 2, x plus 7. So that'd be the complete factoring. So look for common factors, because they'll, some problems will have that kind of built in. All right, let's try this one. Ooh, x to the fifth. Okay, sometimes students get intimidated by bigger exponents. Okay, there's 5x's there, there's 4x's there, there's 3x's there. They have 3x's in common. Okay, so if I take 3 away from this term, I have 2 left. Okay, if I take 3x away from that, it'd be 1. And if I take all 3x away from that, I'd have an 18. Okay, so, alright, positive 18. 1 times 18, 2 times 9, 3 times 6, adds up to 19, adds up to 11, adds up to 9. Okay, here's 11, but it's negative, so negative 2 and a negative 9, right? So here's our final answer. X cubed, x minus 2, x minus 9. Alright, okay. Now sometimes, it can be a little intimidating to see a negative in front. Okay. Alright, but look, we got x is here, x is here, x is here. Okay. So common factoring. Do that common factoring, and sometimes what's left will not be factorable. Most of the time it will be. So I'm gonna put this way. Okay. So x, but I don't like to factor when there's a negative in front. Okay. So I'm going to pull out a negative 1 also. See? Let me back up a second and say it like this. This is negative 1 times x to the third, really. This is a negative 1 times a positive 12 times x squared. Think about it. And this last term is really a negative 1 times a positive 11 times an x. Okay, so really if you think about it, they also have a negative 1 in common if you kind of change it like that. And they all have an x in common. This is 3x's here. This is 2x's here. This is only 1x. So I'm going to write like this. I'm going to pull out a negative 1 and an x. So negative 1x. Parentheses. Okay. So I have x squared right there for the first term. Alright, pull a negative 1, so I have a positive 12 this time. Pull one of the x away, so I have x. And I pull the negative 1 out on the outside, so I have a positive 11. Pull that x away. Okay? And you can always verify and say, look, is this really right? Let's double check. Okay, negative x times x squared, that's a negative x to the third. Negative x times a positive 12x, that's a negative 12x squared. And negative x times 11, that's a negative 11x. And that's what we start with. Okay? Alright, so we verify we're good. Okay? And if you can pull out a common factor, these problems are really designed for you to factor further almost all the time. Okay, positive 11, that's a prime number. The only thing I multiply and make 11 is a 1 times 11. Okay, that's a positive 12 plus 1 plus 11. Okay, 1 times 11, that's 11. Just to check, 1 plus 11, that's my middle number, 12. Alright, I think I have one more to look at, and I'll tell you the rules. Okay, so this one just starts with that little silly little negative sign in front. Here's a quick little way of doing it. Just put a negative 1 and then change all these signs. It's perfectly legitimate. It's not anything I'm making up. Change that. Change that. Okay. This is perfectly correct. You multiply negative 1 times those terms, you distribute, you get the same. You start with the same thing, you get back what you started with. Alright? So we're going to have a negative 1. We're going to factor this. It's a negative 10. So one of the rules is one of them is positive, one is negative. And from a lot of experience, I know my 1 and 10 are not going to do anything, because I'm going to get a 9 or a negative 9. Alright, that's not going to help me. So let's focus on these two. This one or this one. These two add up to be a negative 3. These two add up to be a positive 3. I have a negative 3, so I'm going to use this one. X plus 2, x minus 5. And that's it. Okay, so that's the end of my examples. So let me tell you the rules. And we're all a little bit different, and a lot of people just love the rules, which is fine. I don't have any problem. I really recommend you go through what I just did, practice, and these rules will make really good sense. Okay, so I'll put blank. Well, I'll start with x squared. Okay, I'm doing the simplest case. Okay, let me try one more time. One more time. You have an x squared term, you have an x term, and you have some number. Okay, so you're going to have two signs. So these are basically the rules. In between the last two terms, you're going to have either plus sign or minus sign. If you have a plus sign, that means either both your factors have both a plus in them in the middle, or they both have a minus in the middle. Okay, which one is it? Okay, if the term in the middle is a minus, you have two minus terms. If the sign of the middle term is a positive, you have two positive. Okay, so kind of go like this. I'll do it again. Okay, so you got a plus back here. Okay, so x squared x, you got a plus, you got some number. Okay, if that's a plus here, okay, both of these are pluses, and there's going to be some number back there. All right. Okay, you still got a plus at the end. Okay, now you have a minus in there. Okay, they're both minus this time. Okay, all right, and that's why I don't like this way. Okay, so we have that maybe. We have that maybe. All right. So the other possibilities at the very end. You always look at the end first. You could have a subtract sign there. Now that guarantees you that when you do your factors, one of them is positive, one is negative. Okay. All right. So how are you going to know which? Okay. All right. So if your sign inside there is also negative, that means the larger number has to be negative. Okay. If your factors are 4 and 2, okay, that'd be negative and that'd be positive. They have to be different. This negative right here says they have to be different. Okay. All right. So what if it's you have a positive? Your last term is negative, but you have a positive. That means your larger number is positive. So if your two numbers are again 4 and 2, well, now it's positive. Okay. All right. So try to write this out. So more general terms. Okay. Okay. All right. If the last term is positive, all right, both factors have either both plus or minus. Okay. Okay. They have a plus. They have a plus if the middle is plus. They're both minus if the middle is subtract. Okay. All right. The other thing is, that's other possibility. Last term is negative, or you see a subtract sign. That's what that means. Okay. All right. One factor has a plus. Other factor has a minus. Okay. All right. So how you know which to use? Okay. All right. Let's see. Okay, which one to use? Boy, it makes me have to think. Okay, if your middle term. So this is where you say if your middle term is positive, then your larger factor is positive. if your middle term is negative, then your larger term is negative. Okay, so that's the rules. And don't recommend you really try to memorize those. They're just going to come to you naturally when you do a lot of problems.